How do you prove properties of regular polygons? Have you ever wondered how mathematicians prove the properties of regular polygons? These fascinating shapes are not just pretty to look at, they have a lot of interesting characteristics. Let's break down how we can prove these properties step by step. First, it is essential to know that a regular polygon has all sides equal in length and all interior angles equal in measure. This basic definition is the foundation for proving various properties. To start, we can divide the polygon into congruent isosceles triangles. By drawing lines, known as radii, from the center of the polygon to each vertex, we create several identical triangles. The number of triangles corresponds to the number of sides in the polygon. Each triangle has two equal sides, which are the radii, and a vertex angle that measures 360 degrees divided by the number of sides. Next, we can prove that all side lengths and angles are equal. Since the triangles are congruent, the sides opposite the equal central angles must also be equal. This confirms that all sides of the polygon are the same length. Additionally, the base angles of these triangles are equal, leading to all interior angles of the polygon being equal as well. Now, let's talk about finding the area of the polygon. The apothem is the perpendicular distance from the center to a side. The area of each isosceles triangle can be calculated using the formula 1/2 times the side length times the apothem. By summing the areas of all the triangles, we arrive at the formula for the polygon's area, which is 1/2 times the apothem times the perimeter. Trigonometry can also help us derive formulas related to regular polygons. Using the central angle, we can express the side length, apothem, and radius in terms of trigonometric functions. For example, the side length can be calculated as 2 times the radius times the sine of 180 degrees divided by the number of sides. The apothem can be found using the radius times the cosine of 180 degrees divided by the number of sides. These relationships are useful for proving formulas for perimeter and area. Another interesting property is the sum of interior angles. The sum of the interior angles of any polygon can be calculated using the formula, which is the number of sides minus 2 times 180 degrees. For regular polygons, since all angles are equal, each interior angle can be found by dividing the total sum by the number of sides. Finally, as the number of sides increases, a regular polygon begins to resemble a circle. This connection helps prove that the area of the polygon approaches the area of a circle with a radius equal to the polygon's radius. Understanding these properties of regular polygons is not just an academic exercise. They have practical applications in design, engineering, and even art. By breaking down a regular polygon into simpler shapes and applying basic geometric and trigonometric principles, we can clearly prove its key properties in a straightforward and understandable way.